Speedup. When we consider parallel systems, we use the speedup term to define the ratio between the serial execution time and the parallel execution time. And this measure will be used to know if when I'm adding more parallel processes or parallel resources, I get more performance. Let's look at a typical curve. So this is the ideal speedup curve. Okay. In this curve, when I'm adding 15 processors, using 15 processors for my execution, I'm getting a speedup of 15. Okay. So that means I've divided by 15 my execution time. However, in practice, usually you don't get always this ideal speedup. And the real curve is below the ideal speedup curve. And this one of the reasons why you're losing this efficiency is because when you are adding more resources in parallel, managing them is costing more and more compared to the execution time, to the operations you have to do. And so the real curve starts to be way below the one you would like to have. So the measurement for that is efficiency. Okay? The efficiency is the serial execution time divided by P times the parallel execution time. And the parallel efficiency in the best case is 1. That is, if Tp equal T1 over P, okay, that is, I have divided my serial time P times. In that case, my efficiency is 1. In that case, we say that the algorithm, the application, is very scalable. This is what we call strong scaling. Okay. However, this is rarely achieved. Usually, when you have a fixed workload, that doesn't happen because at some point you get too many resources and you don't get enough work to give them. Typically, assume you have 10 tasks, 100 process, 90 process won't do anything. So the more you will be adding processes, the less your efficiency will be. This is typical curve for speedups. So there is 2 points you want to notice. This one and this one. This one is when you're not getting more performance from parallel execution. So before you saturated the compute unit and you get more performance. At some point you're throwing more resources, parallel resources, but you're not getting performance. The performance might be stable for some times, and at some point it will start to decrease. And one of the reasons is the management of the parallel execution is taking some overheads, and this overhead is starting to impact strongly on the execution time. And so usually you want to keep the number of parallel resources small enough so you get some benefit in terms of performance, and you obviously don't want to be there. Here are the questions for this course. So what are the causes for low efficiency? Should you take the speedups, so that is T1 again the slowest execution possible or the fastest execution possible? How is the speedup linked to energy consumption? Can speedup be superlinear? Does the speedup curve be above the ideal speedup curve, the red one before? And what is the point of diminishing return has to do with power consumption? Some references, so the multi-core book and another one from David Cook. See you in class.